everyone. I'm Kaustubh, founder of AviRob. So yesterday we had a panel discussion about robot safety. A fellow over here asked a question about robot safety, and we got an answer like the safety is for the second generation people, like not us. So I disagree a bit on that statement. Safety is something very hard topic right now. Like it's a real bottleneck. Not because it's very expensive to do or something, but it's really hard because you have your messy logs and you need to prove the safety behavior from that. I will make this talk simple. In next 15 minutes, I will tell you what is robotic safety and what standards are applicable for robots. As ROS people, we love to talk about nav, SLAM, reinforcement learning, but a safety engineer will ask you a very different set of questions. You can see the image. What is the maximum speed? They will ask you. What was the stopping distance? They will ask you this type of questions. Now, you have to prove these kind of answers if you want to deploy your robots into real factories, into real field. That is the difference between your cool robots and an actual robot that can be deployed into factories. I have been talking with a lot of people and I have made 4 levels of thinking. Level 1 brain. I walked in front of the robot and it stopped. Okay, it's a demo. It's not safe. We have level 2 of thinking. We have the LiDAR. Our LiDAR is PLD rating. We have the safety PLC. Okay, it's a step for your safety, but it's not a proof for your safety behavior. Then we come with the level 3. You say we map all the logs, we have all the logs, and we can dig through it if any incident or something happens. Okay, it's time consuming and it's very slow. Now we come to the level 4 of thinking. We map our logs according to the safety standard clause. So what I am doing, I am making the level 4 part very easy to do for anyone. I think you all are well aware of this meme. You made the cool robot but failed to deploy when the customer asked you for where's the certification? Yeah. So this safety standard is like a 100-page big rule book. You need to read a lot, debate a lot, think a lot about everything. So I won't spend much time into the technical because you will be bored. Sorry for the slide. Too much technical, I know. I got a small snippet of the safety standard. You must have at least the basic of it to actually deploy it into a factory or like where you're deploying it. I won't go into the technical. I will move to the next slide. This is the deployment reality. In India, safety standards are not that mandate. There's no need to get certified, but the risk is on you. You have the insurance. If the big customer asks you for the certification or the evidence, if something happens, then you have to show them the numbers, not your demo. If you are planning to go for Europe or global market, they are very strict with their safety standard. You are not allowed to deploy your robots without the actual certification. They have the certification name in their brochure when they sell their robots. That is a core selling point for them. So from the start, I'm talking about standards. What is a standard? What is Type C? Type C cable? No. Type C is a rule book for specific machine. Quick context, you have 3 types, Type A, Type B, and Type C. Type A is basic idea for the safety, Type B is the general safety, and Type C is specific to a machine. So if you have a mobile robot, you have ISO 3691 Part 4 standard for functional safety and other. For robotic arm, you have different set of standards. For cobots, you have different sets. So you have specific Type C standard for each kind of robots. As I said, Type C standard is the gateway. You have your cool robots, and you have the gateway, that is the standard, safety standard, and on the right side, you see the industrial product. So you need to pass through this gateway to actually deploy into the market. Many teams do the engineering, but they struggle to produce a proof or the safety behavior of your robots. So how do we solve this? At AviRob, we build log-based monitoring system for your robots. We get your logs, we put into a general format, and give you a detailed report according to the safety standards. We don't change the hardware or any safety PLC. We only read your logs and output you the result. Moving on to the block diagram, it's a bit complex, telling about the use case and the whole story. To sum it up, I have a demo video which will make sense after all this. I will go in short. So the story is, you have your robot, your fleet of robots. Our software collects all those logs. You have your FMS, fleet management system. We collect the logs according to the safety standards, what all we need. We map them to each clause. We do our calculation, and the use case are at the bottom layer. During a development, during a deployment for FAT or SAT test, they are basically factory and site acceptance test. During your fleet monitoring for your the safety of fleet monitoring, and for the maintenance work. For example, you deployed a mobile robot, and the stopping distance was 3 meters, just an example. But your braking system may degrade according to time. Okay, your robot may start overspeeding due to wheel slippage. How you will predict that? Do you have an AI model? Okay, you can train an AI model. Do you have data? No. So we do a 10 analysis of the robot. You get the accurate time or the accurate alarm when your robot is going to make a disaster. You get a risk hotspot. Okay, this area is likely more highly likely to have some risk. I went to multiple events and I got a comment from people. We deployed our robot into some warehouse and people are playing with it. They are putting their legs in front of the robot and see, okay, it stops working. Yeah. And one day, the robot had the maximum load capacity, like a few tons. And a person came and just do like this in front of the robot. What do you think would happen? Yeah, the robot was safe. It had been certified. It stopped. But due to that, it got damage into the braking system. So they called the manufacturer side, see, your robot is not working, do something. And they saw from their logs, like they took weeks to get to know what actually happened. And they say, okay, at this point only, every time when the robot comes at this spot, the robot stops. Why it's happening? So you never know. It can be an oil slippage or a person playing with that robot. So we give you a heat map for your robot. Like you have a map where it is deployed. We give you a heat map where you can see the maximum risk coming up from the robot. So I will run a demo video how we tackle the safety standard. I will do into the full screen. 1 second. over here you can see the clause-wise verdict for it. It was a demo run, which is guaranteed to be failed. Yeah. For a demo, I can show you what we do. You have all the clause, and there are many more. For demo, I reduced the length so you can read it. So the clause 4.1.1, that is about the zone speed. Does your robot actually is in the safety limit for that zone? So the test failed. For braking, the test passed. The rated speed. Rated speed is given by the manufacturer side. For example, if you provide 1.2 meter per second, 1.8 meter per second, just an example. Your robot can go much higher than the rated speed because of the wheel slippage or something. There can be multiple issues. You never know. You get the exact overspeed event when it started, when it happened. The C1, C2, C3 is the distance from the side. C1 and C2 means distance from the either side. It can be either left or right. C3 is the front distance, like available for your robot to move. Yeah, that's it. So long story short, what we got from one single run, we got your all configuration from your robot. We have all the configurations. For example, you have n number of robots. So for each robot, you have a robot ID. You have big warehouse, so you have the site area like zone A, zone B, zone C for different type. Then we capture the stopping behavior. We capture the modes, and at the last, you can see the clause view, which I skipped. You can map the clause from the last one. We have a clause view, which you didn't want to read it out. Okay. So how team can use it? During your development, like you are building your robot, you can easily catch the safety behavior. When you are going for deployment, you have a new environment, you can do the safety checks again in matter of seconds. We give you the scenario, you have to run your robots, and you get the safety report. You have your factory acceptance test, you have your site acceptance test. For the end users, it will be really helpful to manage the safety behavior for full fleet. And obviously, very helpful for the integrators. So, ending this out, if you have any question, you can scan the QR code. You will go to my website. If you want to talk more about in person, I will take a deep dive with a cup of coffee. And thank you.